All right, so this second part of Unit 8 is going to be about electrochemistry, looking at how chemical reactions are able to provide energy that can be used in electrical applications and vice versa. This first video is going to review some content that we covered back towards the beginning of the year. It's going to be a real short and sweet video, but I just want to review with you how we talked about redox reactions, the components of them, and how we balance redox reactions. Some of those pieces will be of help to you in the galvanic cells and the electrolytic cells that we're going to discuss. So, when you have a redox reaction, you have some substance losing electrons to another substance which is gaining those electrons. The substance which is losing the electrons is undergoing oxidation, and the substance that's gaining the electrons is undergoing reduction. To lose the electrons, you're facilitating that reduction process. So the entire substance containing the oxidizing element is known as the reducing agent, and the entire substance undergoing the reduction, the element that's a part of it that's undergoing reduction, is considered to be the oxidizing agent. So you need both components in a redox reaction. You need something to lose the electrons and something to gain them. And remember when we did these back in the day, once you had your two half reactions, we'll go back over how we decided to use the hydrogens and the waters and stuff like that. You needed to make sure that your electrons were balanced along with your atoms. So we needed conservation of mass for both elements and for electrons, and so that the overall charge on both sides of a half reaction would be balanced. So, in order to balance those oxidation reduction half reactions, you're going to have a chart you're going to get to use for a lot of these, but you always want to make sure that your elements are balanced. Don't worry about hydrogen and oxygen. We're going to balance oxygen with water, and then we'll balance hydrogen with hydrogen ions. I'm not going to make you switch back and forth between acidic and basic. You're going to be able to just do that first part, the oxygen with water and the hydrogen with hydrogen ions. And then you want to make sure you balance out your charge. Something has to have electrons on the reactant side if it's gaining them. And the other half reaction has to have electrons on the product side because they're losing them. So just a quick review as to how to balance an half reactions or balance an equation by half reactions. We want to split this particular reaction into its two half reactions, taking both the aluminum components and taking both of the magnesium components. We would check first to see if the elements are balanced, and in this case they are. So the only thing we have left to do is to balance the electrons. We have a +3 charge on the reactant side. We have a neutral charge on the product side. So since electrons are going to reduce our charge, we're going to add those to the aluminum side, giving us the 3 electrons. Sorry, I couldn't remember if I did the magnesium one yet or not. Same thing with the magnesium half reaction. We see that there's 1 magnesium on both sides of the equation. The magnesium on the reactant side is neutral. The magnesium on the product side has a +2 charge. So we're going to need to add electrons to the product side to balance out that +2 charge with the magnesium cation. So at this point, we have our two half reactions. We can tell the aluminum ions are going to be going through reduction, and that the magnesium metal is undergoing oxidation. What we also can see is that the number of electrons between the two half reactions are not balanced. We have 3 electrons being gained by the aluminum ions and 2 electrons being lost by magnesium. So the factor they both would have in common would be 6. So if I multiply both sides of the equation by 2 with the aluminum and by 3 with magnesium, I now will have 6 electrons on both sides of the equation. The number of electrons being lost are going to equal the number of electrons being gained. The 2 and the 3 are coefficients distributed through to the entire equation, so we would now have 6 electrons and 2 aluminum ions, making 2 aluminum atoms, 3 magnesium atoms, making 3 magnesium ions, and 6 electrons. The electrons get canceled, and when we combine the two half reactions together, we see that we have 2 aluminum ions and 3 magnesium atoms make 2 aluminum atoms and 3 magnesium ions, +6 charge on the reactant side, +6 charge on the product side. So this would be a balanced equation. Okay, none of this was in your notes. This was just meant to review what we had talked about previously so that you would be prepared for something like what you just saw on the last slide.